So the purpose of this video is to talk about Bayes' theorem real quick. And so the only reason that we need Bayes' theorem in this particular lesson is so that we can flip a conditional probability. So for example, if you had the probability that x, random variable x is equal to x, given y is equal to 0, where this is your class, so we're trying to classify this thing. What we want to do is we want to find, so given that we own, or that we know this, let me erase that. Given that we know this, what I want to be able to do is I want to turn it around and say the probability that we're in class 0 given that x is equal to x. So that's what we want to be able to do, and that's what you'll see in the Jupyter Notebook tonight. But in order to do that, you got to kind of understand or remember a couple things from Bayes' theorem. So all I'm going to do is take you through an example where we would have certain pieces of information, and then we'll do what's called the law of total probability. You'll see that down here as well, the law of total probability. It's fairly straightforward, and then we'll use that in order to find Bayes' theorem and to be able to flip this thing from looking at this probability to looking at this probability. Okay, so the example is that we have an email, and an email, and it's either a spam or it's not a spam, and it's either coming from one of 3 accounts. I don't know, the first account might be your Hotmail account, maybe you have a Gmail account, and maybe you have your West Point account. So that'll be our 3 that I'll talk about, if I can remember them in that order. So those are my events. So A sub I, A sub 1 will be coming from my Hotmail, A sub 2 will be coming from my Gmail, and A sub 3 will be coming from my West Point account. And then B will be either that it's spam or not spam, right? So those are the 2 things I'm going to classify this thing in as. And further, let's just know that we can find the distribution. So I can definitely find the distribution of all the emails that are coming from account 1. Why? Well, I have a history, right? So I can look at how many of my emails are coming from the Hotmail account. Well, 70% of them out of all of the total, right? So all you would do is add up the total number of emails that came from Hotmail and divide it by the total number of emails that you got. So that's fairly straightforward, and that's what you're going to be doing in the actual with the data. So when you're trying to, but these are called prior distributions. And if you were given no other information other than, hey, this thing, you just got an email, then you would probably say, there's a 70% chance that it came from here, 20% chance from here, and 10% chance from there. So that's your prior distribution without any other information. Inside this 70%, we know, say there's 1,000 emails. Well, maybe only 1 out of 100 are actually spam. And we could calculate that, given that we classified each one of our emails as either spam or not spam. And I could actually come up with this number, 0.01, right? So that's not that big a deal. And we could actually do the same thing with our ones that are coming from your Gmail, and then maybe even the ones that are coming from, West Point's getting, or my West Point account is getting hit kind of hard from somebody. So 5% of those smaller number is spam. Okay, so we could definitely calculate these probabilities here. But here's the deal: is what we're going to do down low here is I'm going to flip this thing, right? So remember what we're trying to do here is this is a conditional probability. So this is the probability of getting a spam given that it comes from your Gmail account. Well, we know that we can calculate that from the data. Not a big deal. 0.01. What's the probability of spam given that you're coming from I'm sorry, this one's Hotmail, I think. This is Gmail, right? And then again, we could calculate. So these probabilities, conditional probabilities, actually mean something. Okay, so here's the sample space, and I'll just put the symbol for sample space out here. The entire sample space, what does this mean? Well, this means that we can only get emails from Hotmail, from Gmail, and from my West Point account. There are no other emails that can come into this system that we're talking about. And then what I've done is I've taken this B, this second event, and put it on top of this mutually exclusive and exhaustive list of events, right? So that's what A's represent. A1 is a mutually, A1, A2, and A3 are all mutually exclusive, meaning they don't overlap, and they're they're exhaustive, meaning they eat up the entire sample space. So if that's true with those events, then you can calculate the probability of B using that information, right? So if I was going to use the total probability, I'd say, well, the probability of B is going to be equal to the probability of A1 intersect B, right? So that would be this little bit in here. A2 intersect B, which would be that amount of probabilities in there. and then A3 intersect B, which would be that probability. Well, we know how to use conditional probabilities and the intersection because we know that this is also equal to the probability of B given A1 times probability of A1. We know this from conditional probability. So I already know this is 0.01, and I know the probability of A1 is 70%. So I can calculate these numbers. So I can calculate the probability of A1 intersect B. I can calculate that amount of probability in there. I can use these numbers to calculate the amount of probability in this little piece of that circle. And I can use these numbers to calculate this the amount of probability in that little sucker. So if you do all that, you'll get 0.016. So the probability of me getting a spam email is 0.016. So again, all you're doing is multiplying those suckers out using conditional probabilities and finding that guy. Okay, remember what we want to do though. I don't want B given A1. I want A1 given B. So that's the next question is how do we calculate A1 given B? How do we flip it? Well, you find that you have the same intersection or this A1 intersect B1. So what we're talking about is this given or divided by the total divided by probability of B. So what we're saying now is B occurred. So if you want to think about it, B it definitely occurred. So that becomes my new sample space, and that's why it's on the bottom down there, the probability of B. And then what you're trying to do now is calculate this A1 intersect B, which, oh, by the way, we know we can calculate that with conditional probability. So again, if you did all that, you would and put it in the calculator there, you get 0.4375. Did the same thing with A2, you would get 0.025, and the same thing with A3, 3.125. And multiply or add up all those suckers, and hopefully you get 1. So with no information, what I'm telling you is if a message comes in, we think we have a 70% chance of coming from account 1, 20% from account 2, and 10% account 3. That's saying I have no information about it. However, if I tell you, hey, this message is spam, or I could do exactly the same thing with B prime, in other words, not spam, and try to figure out what distribution it comes from, or what email account it comes from. But with this new amount of information, hey, listen, you just got a spam. So the question is, what is the probability that it came from A1 given that it is spam is now, the 0.4375. And without Bayes' theorem or without thinking about this, about flipping that conditional probability, you would not be able to calculate that one. Okay, 7 minutes down. That's all I got. Hopefully you got something out of this. Being able to flip that conditional probability is all we're trying to do, and we're utilizing the fact that A1 intersect B is the same for both of the when you're flipping them.